assignment book. Okay, and also the white worksheet. Do not forget to do the white worksheet, and I'll go over that in a minute on another video after this one. Okay, so the first one, it says mirror, mirror, reflection. Okay, you're going to do all these problems. This graph is for A through I. Wow. A lot of one graph relates to all the question. Okay. Plot the following points and connect them with a straight line in order which they are given. So plot it in the order they are given. Connect the last point to the first point and label it figure 1. Label it 1. Okay. Okay, so 0, 0, right there. I'm gonna close this in, okay? Sorry if I get in and out too much. 0, 0, negative 7, 5, negative 7, 5. Okay, and then 7, 8, negative 7, 8, negative 7, 8. I'll go up to 8. So connect the dots. Okay, so I don't forget which order. Let's try a little bit straighter. Oh well. Wish I had a ruler. Okay. Nope, not straight enough. There. Alright, and then negative 4, 8. Negative 4, 8. I hope I did it right. Okay, negative 4, 8. That's it. Oh, it looks like a kite. So if you connect this like that, and the last dot to the first dot, there you go. Okay, and label it 1. We'll leave this as 1. Alright, list the ordered pair in quadrant 1. List the ordered pair of quadrilateral 1 if it reflects over the y-axis. Okay, if it reflects over the y-axis, the y stays the same. Okay, and x changes. Just so you do, when you do this, switch 1 over, count 3 over right there, and it'll be right there. Alright? And count 4 over, I'm sorry, and it'll be right there. So, determine how you can, oh, I didn't read, see? Determine how you can, explain how you can determine the ordered pair of the reflection without graphing. Well, just to make sure, you just do yourself a favor and graph it. And this was negative 4, 8. So this becomes 4, 8. So as you can see, reflecting over the y stays the same, the x becomes its opposite. And you write that in math, x becomes its opposite, you write it negative x, and y stays the same. You do nothing to y. Notice the y has no change, and the x has a negative. That's saying x is to the negative. That's the rule. Okay, this is the rule or the pattern for this, that the x becomes its opposite and the y stays the same. So when you write it algebraically, it looks like this is the rule. Okay? So list the ordered pair, explain how. Okay, well, they didn't want us to graph it, but I'm just explaining to you. Okay, so the ordered pair is x becomes its opposite. The opposite of 0 is still 0 and 0. O. The opposite of negative 7 is a positive 7 and 5. Y stays the same. The opposite of negative 7 is 7 and the Y stays the same. And the opposite of negative 4 is 4 and the Y stays the same. Okay? Explain how you determine the ordered pair. Okay, you can say the opposite of X and Y stays the same. We should say coordinate. Y stays the same. I bet you they want the word coordinate here. But anyways, plot and label it 2. Oh, okay. 0, 0, 7, 5, 7, 8, 7, 5, 7, 8, 4, 8, connect it, and label it 2. Perfect. That's C. Okay, list the ordered pair quadrant 2, a quadrilateral 2, and reflect it over. List the ordered pair quadrilateral 2 if it reflects over the x-axis. Okay, so this is quadrilateral 2 and reflect it over this x-axis. So this x-axis becomes its perpendicular bisector now. So on the other side, so if we reflect it, okay, this goes 1, 2, 3, 4, 5 away, 1, 2, 3, 4, 5 away. It's over here, so it's 7, negative 5. So this is 7, 5. So notice the change here. Like that. They just want you. So over the x, the x stays the same and the y becomes its opposite. There's so many different rules, so you want to test it out just to make sure your thinking is correct. Okay, list the ordered pair, explain. Okay, so we're going to list it. Okay, let's see, the other one is 0, 7, so the opposite. Okay, without graphing, so the rule is the y become its opposite. X stays the same, so you just write x, and y becomes its opposite, so you put that negative y there. Okay, the first is 0, 0, so that doesn't change any. Opposite of 0 is 0. 7, 7, 5. Sorry, I know it's these numbers, I can't remember them. 7, 5. The opposite of y is negative 5, and 7, 8, so the opposite of y is negative 8, because right here it's a positive 8, so it becomes a negative 8, and then the next one is a positive 8, so it becomes a negative 8. 4 stays the same, and it becomes a negative 8. Okay, plot the reflection and label in part D, and label it 3. Oh my gosh, I hate doing it. It's back and forth. Okay. 0, 0, 7, negative 5, 7, negative 8. Okay, 0, 0 is obviously here. 7, negative 5, right here. 7, negative 8, they don't want you to write it, but 4, 8, I believe, right, 4, negative 8, yep, that's it, right there, and go back to 0, 0. Okay, and label it 3, I believe it says. Okay, now, Plot and label 3. F. List the ordered pair for quadrilateral 1 as it reflects over the x-axis. Explain, okay. Quadrilateral 1 over the x-axis? No, this one over the x-axis. The blue one there, put it over here. And, well, this is easy, because it keeps doing the same thing over and over. Okay? So, the x-axis becomes its bisector. These are our numbers right here. Over the x, if it's over the x stays the same, and the y becomes its opposite. So how do we write that? The x stays the same, so it stays letter x, and y becomes its opposite. 0, 0 is still 0, 0. The other one, sorry you guys, negative 7, 5, negative 7, 8, negative 7, 5. X stays the same, y becomes its opposite. Negative 7, 8. X stays the same, y becomes its opposite. And I believe negative 4, 8. So is, yeah, the original one. Let me look just to make sure. Negative 4, 8. Yep, that's what it's. Negative 4, 8 reflect over the x. Therefore, x stays the same, and y becomes its opposite. So opposite of 8 is negative 8. And I'm sure they want you to plot. Oh, explain how you can determine the ordered pair without graphing. Okay, we determine without graphing is the x stays the same, x coordinate. We need to use the word coordinate, sorry. Stays the same. And the y becomes its opposite. Okay, like that. And this one here, the x stays the same, the x coordinate. And the y becomes its opposite. Okay? Okay. Then graph it and label it 4, right? Graph these coordinates back over there in the original. So you should have another graph right here. I don't, okay, 7, negative 5, negative 7, negative 5, negative 7, negative 8, negative 4, negative 8, like that, and figure 4. Okay? That's what you should get. Alright. Write a general statement determining the ordered pair of vertices if it's reflect over the x. The x coordinate stays the same. Stays the same. And the y becomes its opposite. Wow, they want the y coordinate. They want you to write this over and over so you can remember, huh? Y coordinate becomes its opposite. And that, because y becomes its opposite, x stays the same, so it stays x. Y becomes its opposite, negative. Okay, well, you know this one. The y coordinate stay the same, and the x coordinate becomes its opposite. Okay, sake of time, you write that down. So it'll take forever to graph it. Oh, y is 2. y is 2, right there. The graph shows a triangle and the line y equals 2, right here. Okay. List the ordered pair of the vertices of triangle 1. Okay, list the ordered pair. 8, 5, 6, 9, and 2, 5. Okay, so we do 2, 5, 6, 9, 8, 5. I wish they give letters. Reflect triangle 1 over the y2. Label it reflection 2. Okay, reflected over here. Well, the y equals 2 is now your perpendicular bisector. And it's 3 away, so you count 1, 2, 3 right there. 1, 2, 3 here. 1, 2, 3 there. Okay, let's erase all the little marks. Looks ugly. Okay, so connect that for that line. And this one is 1, 2, 3, 4, 5, 6, 7 away. So you count 1, 2, 3, 4, 5, 6, 7 away. Okay, connect it. Oh, sorry. Oh no, I just don't like all the mess. Erase, 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 erase. Okay, that's it. And label it 2, reflection 2. Okay. List the ordered pairs. Oh, come on. Tedious work. Okay. This is 8, -2. This is 7, -5. This is 2, -2. Remember, the x stayed the same. Reflecting over the x stayed the same, y changes. Oh. Okay, always 2, -2, 8, 8, -2, and 7, -5. What is the relationship between the corresponding, okay, what's the relationship between the corresponding vertices in triangle 1 and triangle 3? Okay, what's the relationship? X are the same. Is it X or Y? These right here. Hold on a minute. Oh, this is C, this is 7. This is 7, 9. Good thing they asked us that because I would have missed it. You guys would pick me out. Again. Careless mistakes. Okay. 7, 9. That's correlated to this and this, and 8 to that. So as you notice, x are all the same. The only difference is there's a change in y. Okay? The x coordinate remained the same because it's reflecting over the x, basically, even though this says y equals 2. Okay? The x coordinate stayed the same. Triangle 2 congruent to triangle 1. Explain why. They're congruent because they're just a reflection, and reflections do not change anything. Triangle 1, triangle 2 is congruent to triangle 1. Triangle 2 is congruent to triangle 1 because it's a reflection, and reflection keeps the shape same size, same. And reflection keeps the shape same size and shape. Keeps the shape keeps the shape the same in size and shape. So basically stating it doesn't change anything, alright? Alright, -3, x -3. Oh, x -3 is right here. Well, they already drew in that line for you. That's now your perpendicular bisector. You ignore the y line. Now it becomes your y line, x equals -3. Okay, list the ordered pairs. 1, -7. 5, -8. 4, -3. Over, okay, x -3. Okay, well, basically the y stay the same. So I'm going to go over 4. 1, 2, 3, 4. 1, 2, 3, 4. This way. And this way it is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And erase so it doesn't look so ugly. The last shape is down here. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right there. Alright, let's connect it. And we got a reflecting over x equals to -3. And label 2. Triangle 2. Okay. Ordered pair is, well, the y is going to be the same. So it's -7 here, -8 here, and -3 here. Alright. The -3, it's -10, -3. The -8 is 11, -8, and then the other one, -7, it's -7, -7. Okay. What's the relationship? The relationship is the y coordinate are the same. This is easy, you guys. Okay. Is they congruent? Yes, it is congruent. Same reason. It is a reflection, and reflections do not change the... Okay, yes, it is congruent. Yes, this is very important you write this though. It is congruent. It's part of geometry. They always write stupid things like this. That's why my son doesn't like it. It's always stating the obvious. Yes, it is congruent because it is a reflection, and reflections, it is a reflection. Reflections do not change the shapes and size of the triangle. The shape and size of the triangle. Reflections do not change the shape or size of anything. Okay? That's why it's congruent. Congruent means exact same shape and exact same size. And the end, thank goodness, right?